All right, today we will continue with your problem solving and with some of the content from this chapter. I have not formally assigned the vocabulary yet, but we will get to that next week. Okay? Now, let me get this up first. Okay, so what have we done for problem solving so far this chapter? Well, that's joules, that's how you label it, but what is it we're talking about? Work and power. What do you label power in?
Oh, that's going to have to watts.
Yeah, it's in watts. Now, what clues did we give yesterday as far as labeling with that of power? Don't get that label mixed up with work. No? Well, yeah, that's true too. But again, if you label power in watts, which you do, make sure you don't get that confused with the variable for work, which is measured in joules. Okay? So some of you may choose to put a smiley face over that letter P for power. That's entirely up to you. Don't get that mixed up with momentum. All right. So we took that one step further. If you want to look at work, if we're dividing that by time, we discuss the idea that how efficiently is that work getting done. All right. So any type of machine, okay? Any type of machine makes work easier. Anything from a paper cutter to a scissors, a crowbar, a hammer, of course, and any other type of machined tool.
Sounds like a person trying to rob someone.
Do you need a writing utensil? Oh, you got one. Okay.
What was that for?
So for some of you farmers, okay, if you have to take a pulley off of one of your main drive belts of your combine, just using that as an example, can you pry that off with a crowbar?
Yes,
You could, but why is that perhaps maybe not a very good idea?
You take your grinder to the belt.
When you say bend something, can you be a little more specific?
Break something.
Scratch the belt. Or you might scratch the belt. If you bend the pulley that bends on it.
Okay, bending something, but not the pulley. Well, I suppose you could, but...
You're going to crack off the cracks or whatever they are in the side of them.
Well, whatever the pulley is actually attached to. Okay? So what I mean is when you have a splined shaft on there and you need to get that pulled off of there. Have you ever heard of a gear puller before?
Yeah, I got one.
Okay? So, for instance, what does a gear puller actually look like?
It looks like a little thing with a bunch of tines.
Doesn't it have claws on it?
Yeah, it's got like 3 of them, and then you got that little deal in the middle.
Right. So as you are tightening that bolt inside of those 3, what would you call them, claws?
Teeth.
3 teeth then. So that is pushing on your spline, and then what is that doing with those claws? It's pulling it this way. So why would it be much better to use that than a crowbar?
That way you don't wreck it.
Okay, but if you use a crowbar, are you moving it evenly? No. That's why you'd want to use a gear puller. So these machines actually make work easier. Yes, that is true. So yes, you could use a crowbar, but it would probably not be a very good idea. Okay? Okay? I would certainly think that inside anybody's machine, well, not anybody's machine shed, all farmers' machine sheds, you probably have a hydraulic jack of some sort.
Yeah, an air jack?
And maybe, I don't know. I would certainly think you'd have a hydraulic lift jack. Okay? So, what is it, as you are pumping that, what are you moving through that system? What type of fluid? Well, hydraulic oil. Well, it depends what type of jack you have. We're talking about a hydraulic lift jack. So it's hydraulic fluid that actually have inside of there. So what you are doing is as you pump that, you are increasing that force on there. Okay? I would certainly, so you have an air jack? Okay. I don't know. I've never utilized one of them before. Okay. All right. Well, I believe you. I just have never, I don't even know if I've seen one before. Okay. So you bring up a good point. Okay. What do you suppose, you're going to answer your own question here. Fire trucks, why would they have those air pillows in there like what you just said? They're lighter and they're much faster. But the only thing that I could think of that might be a bit of a problem with those types of jacks is it might be a little unstable. At least if you have a hydraulic jack, you are controlling that lifting point, probably on some part of a chassis of some sort of whatever it is that you're changing. Okay? Now, what could also be a problem if you have a flat tire on your combine, your back left tire, okay? You need to get that lifted up, and you're out in the middle of your cornfield.
You use your air compressor. You hook up your
Well, you don't have that. It's a hydraulic lift jack, we said.
hook up your air compressor and you put air in the tire. Yeah.
Well, then you get to the other side of the field and it's flat again. Okay. The tire's flat. You can't just put air in it. It's just going to go flat again.
So it has a hole in it.
Right. Okay. So you have your hydraulic lift jack and you're out in the middle of the cornfield. Is there possibly a problem with trying to lift that up with your jack? Right, because if you're not on a concrete platform, every time you pump that up, rather than pushing the device up, it's going to push it down into the ground. So maybe you have a type of plywood base that you could use, or maybe a steel base. Yeah, I don't know. We're just trying to utilize what you do on the farm and make it relevant to what we are talking about here. Okay? And for anyone who's ever had to go through the moving process, let's see here, older, you probably don't have enough material. Some of your older brothers or sisters, like moving Nick. How did you help with that?
Oh, I've had to do it like 12 times.
Yes? Moving Nick.
Parents are a little, I didn't help.
Oh, okay. So, but why, when you're using a moving truck, now maybe your whole family is moving, okay? What is it that you can do to load appliances on that to make it much, much easier as opposed to just brute force lifting that up.
Use ramps at the back ends of moving trucks.
Right. Okay. But now you got the ramp. What else do you utilize with that then?
Need wheels or something.
Say that again.
Like a little
Yeah. I call them dolly carts. I don't know what the real technical term for that would be. Okay. It's something that you have an axle. Okay. If you have that balanced on there, for those of you who have used one, you put your foot up against that axle and you pull back and you got the handles and you start wheeling it around. That is much, much easier than trying to lift that appliance from the ground up into the truck. Requires a lot less force. Yes. Okay. So one more slide. I want to get through this one. Then we're going to discuss a problem behind the board here. Or the screen. Although you'll see an example of what I want to say, not necessarily a man or bionic woman, what would that possibly mean?
They don't have
Yeah, so biometrics, how they can actually use that to, for me it's hard to explain. You'll see that within the next half hour.
Do you have a peanut? I hope you pencil either.
Probably, yeah.
Mine doesn't work.
Can you catch?
I suppose. Kobe. You want the one without lead?
No, thank you.
Okay, fair enough.
And I guess for me, the first thing that I think of when it comes to these actuators, which is really a type of piston, for those of you who've seen, what is it, the first Iron Man, where, yes, he's in the cave and he makes that suit, and I think those are electrical actuators. It's not moving fluid, but maybe it is. It's been a long time since I've seen that, but that type of a device actually magnifies the output force just like hydraulic jacks would. Okay. But look at what we're saying here. The ramp may have a longer distance, but it's going to take a lot less force to move up that incline, probably half or less, just because you're going up an inclined plane, which makes the work easier. That's why you have them. And sometimes, for those of you, I think we've said this before, many times you've heard that phrase, work smarter, not harder. Well, what happens if your snowblower quits working, but you still have to get snow off your driveway? Well, then you don't have a choice. Then you got to use your shovel.
Fix your snowblower.
Well, maybe fix it, yeah. I do.
Do you enjoy using it?
No, because then there's snow on the ground.
You don't like snow? You don't like snow?
Not when I got to shovel it, no. Does everyone have this content that wants it?
Yeah.
All right. So there's on CBS every Wednesday night, 8 o'clock, it's a show called Tough as Nails. Has anyone ever heard of that?
Yes.
Has anyone watched it?
No.
Okay, last night
You watch it?
name 5 branches of the U.S. Armed Forces.
Coast Guard, Navy, Army, military.
And what's so unique about that, you named the first one that I was looking for. of all of those branches, the Army, Navy, the Air Force, and the Marines, and then the Coast Guard, the fifth one, is actually the smallest of the 5 armed forces. But it's also the toughest to get into. Okay? Coast Guard.
Do you have compound turbos in your Avalanche?
No. All right. So one of the things when it comes to, I think I got that spelled right. Is that how you spell buoy? Bouyey. I think that's right. Okay. So in the show last night, in this competition, let's say, and we've had to do this on the farm before too. You have a rusted hex nut on a bolt. You don't want to break it off. What can you do to that hex nut to get that off? Yeah, if that's not working. That's not working. Say that again. So typically, but I don't understand all the internal mechanisms of this, because when I think about that, if you take a cutting torch, okay, let's say, okay, this is your bolt, this is the hex nut that you have on there. If you're taking that cutting torch and you're heating this up, that hex nut, aren't you heating up the bolt itself? Maybe not as much, maybe this just insulates it. Well, maybe, I don't know. But in this case, when they're replacing these, I don't know if you want to call them shackle pins on these buoys, so there's something about like, that's the shape that you want that to get, so you don't have to put a pin through there so it doesn't slip out, because these chains that they actually use are pretty darn big. And so they heat up the end of that, so they mushroom that out, so then again the top of it would look like that instead of that. So rather than being straight, you heat that up and you mushroom that out, so then that pin can't slip through again. Okay, this is going to be a new formula. Okay, because how many variables do you see up there?
2.
There's only 2, but how many different types of numbers? 3. Okay. So in this case, you have a force and an effort. I did that wrong. That's what I meant to write. Okay? So what that means is those are called little subscripts, just like this. When you're doing velocity, how do you tell the difference between those two? Okay? So you'd have initial velocity, final velocity. Okay? And you had that on your formula sheet. So now, what this means is we've got an effort force, an effort distance, a resistance force, and then a resistance distance. So though you set those two equal to each other, I'll get to that in just a moment. Okay. So then, as we move forward, you got 4 variables. You have to know how many. You have to know 3 of them. Okay? So with this, once you look at the terminology here, it'll tell you which variable you actually have. Okay? So in your case, your question was what? Sorry. Okay? Well, how far does the...
I'm just asking what's the formula?
It's... You could say work out and work in, really, but this is just a simpler way of writing it, because what does force times distance really give you? Work, right? So you could say that work out equals work in, but when you have these different types of variables with a force that you're putting into an object and a resistance force, just from the constraints of this pin. What's that?
Force times work equals distance?
No.
No, force times distance equals work.
Right. Okay. So we want to use the terminology that we see here. Okay. Now, it says a sailor swings with 77 newtons. So if something is measured in newtons, it's telling you that it is a what?
Force.
It's a force. Now, use your intuition here. What do you think that would be? Is that a resistance force or an effort force?
Effort.
Why is it an effort force? Because he's actually talking about putting an effort into it, and then what you had said as well, back row. Because it says you have this much resistance as well. Okay, now, the best thing that you can do is write down what? Okay, so we know that we've got two forces. Okay. Now, you correctly identified the first one. 77 is which one? Okay? So then the resistance force is what? 171. What else do we know in this problem? Okay? Swings with this much force over a distance of 1.7 meters. Oops. So what's the last variable that we're looking for?
We're going to look for a resistance.
The resistance distance. Once you get it to this point, then you just do what the formula tells you to do, which would be what?
That's not funny.
You do your FE times your E.
Ooh, you like that?
Okay? Does that look correct to you? Okay? So the formula tells you to take 77 times 1.70 equals 171 times the distance resistance.
130.9.
Okay?
130.9.
Okay? So then dr, I'm sorry, could you repeat that?
130.9.
I did not word that question correctly, but you're going where the numbers lead you. You did this how we told you to.
That's not what the GR equals. That's not, yeah. we just
Oh,
divide it.
okay. I thought you were giving me the answer.
No.
Okay. You're saying this is 130.
Yeah.
So then what's on our right-hand side?
Equals 171.
Okay. So then distance resistance equals what?
0.777.
That's a lot better. Okay.
I nailed that one.
Okay. Even though that's probably a smaller distance than that, because if we're talking about 0.7 of a meter, this isn't even a meter, so we're already looking at almost this type of a distance. That's not a very good problem, because really you're probably only moving it about like this far, because you got to remember this pin is inside of a shackle that you're trying to flatten out. But we said go where the numbers lead you. That is the right answer. Okay? Oops. So now, left outside. Are we on the bus here?
Yes,
Yes.
sir.
I wait till everyone, so I see everyone nod. Left outside.
Yeah.
Left outside.
Start nodding.
Okay.
Hey,
Middle.
tells you I did not,
Right outside.
not my head now. Don't be
Now, if you have questions or something does not seem clear, I would hope that you would take the initiative or responsibility to get some extra help with that.
Why would you not be writing this down?
Okay. So, that's all I have. We're going to continue that video. We'll catch up to you next time.